Rahmanir Rahim. Our today's lecture is about logic gates. Logic gates are the basic building blocks of any digital system. Whether it's a digital computer or a cell phone, at a basic level, its different components, their different components are constructed using these logic gates. So logic gates are very important in the design of any digital system. The term gate is used to describe a circuit that performs a logical operation. We have two types of operation. One is arithmetic operation and the other is logical operation. Arithmetic operations, they always return some value. For example, when we add two numbers like 2 plus 5 returns 7, 3 into 2 returns 6. Arithmetic operations are like addition, subtraction, multiplication and division. The other type of operations are logical operations. Logical operations return either true or false. The operands of a logical operations are logical statements. There are three basic logical operations: not logical operation, and logical operation, and or logical operation. And or logical operations are binary operation. They require at least two operands. Not logical operation is a unary operation. It requires a single operand. We have three basic logical operations and we have three basic logic gates. We have not logical operation. So to perform logical operation through a circuit, we have a NOT gate or inverter. A gate, inverter or a NOT gate, a gate that performs not logical operation. So this is the symbol of NOT gate or an inverter. It is a unary operation, that's why it has a single input. On the left side of the gate, this is the input line, this is the input. Here we feed input to the gate and this is the output. On the right side we have the output of the gate. This bubble shows complementation. This bubble shows complementation or inversion. So when we apply a 1 over here, so we get a 0 at the output. So when we apply a 0 at the input, we get a 1 at the output. This is the operation of NOT gate. AND gate performs AND logical operation. This is the symbol of two input AND gate. So if we have a 3 input gate, so we will have another line, input line over here. If we have 4 input gate, so we will have 4 lines at the input side. The left side again is the input side and the right side, the X, is the output. Since AND is a binary operation and logical operation is a binary operation, that's why an AND gate consists at least of 2 inputs. It requires 2 inputs, so A and B. So this is a logic symbol of AND gate, which performs AND logical operations. The third basic gate is the OR gate. OR gate performs OR logical operation. This is the standard symbol of OR gate. This is a 2 input OR gate, so we have A and B as input on the left side and we have a single output on the right side. So this is the symbol of an OR gate. Inverter or the NOT gate. The inverter performs the operation called inversion or complementation. The inverter changes one logic level to the opposite logic level. If we apply a high logic level at the input, the output of the inverter will be the low logic level. If we apply a low logic level at the input, so the output will be a high logic level. If we apply a 0 at the input, the output will be 1, or if we apply a 1 at the input, the output will be 0. So if we apply a 0 over here, so if we apply a 0 over here, the output will be 1. If we apply a 1 at the input, the output will be 0. Inverter operation. When the input is low, the output is high. When the input is high, the output is low, thereby producing an inverted output. This logical expression or Boolean expression for an inverter is X, the output, equal to A bar. A is the input. If A, look, this is the input and this is the output, A bar. So X is equal to A bar. So what it means? It means if we apply, the output is always complement of the input. If we apply a 0, the output will be a 1. If we apply a 1, the output will be 0. The expression state, this Boolean expression states that the output is complement of the input. So if A is equal to 0, then X is equal to 1. If A is equal to 1, then X is equal to 0. The complemented variable A can be read as A bar or A naught. So this is inverter. The AND gate. An AND gate can have 2 or more inputs and perform what is known as a logical multiplication. The AND gate is composed of 2 or more inputs and a single output as indicated by standard logic symbol. This is the standard logic symbol of an AND gate. Inputs are on the left side and output is on the right side. So A and B, these are the 2 inputs. This is a 2 input AND gate, and this line represents the output represented by a Boolean variable X. Operation of an AND gate. An AND gate produces a high output only when all of the inputs are high. If A is 1, B is 1, the output will be 1. If any of the input is 0, the output will be 0. This is the basic operation of AND gate. So it can be stated as for a 2 input AND gate, output X is high only when input A and B are high. X is low when either A or B is low, or when both A and B are low. So if we look at this case, we have 2 inputs, so we have 4 cases. 2 raised to power n, number of combinations. N is the number of inputs. So we have 2 inputs, so 2 raised to power 2 is equal to 4. So we have 4 cases, 4 combination of the inputs. So this, when both the inputs are 0, 0, the output is 0. When one input is 0, the other input is 1, the output is low. When one input is 0, the other is low, the output is 0. When both the inputs are high, the output is high. Or when both the inputs are 1, the output is 1. So look at this. For only high inputs, both high inputs, the output is high. And if any of the input is low, the output is low. This is what a truth table. A truth table lists all input combination with corresponding output. So look, this is a truth table. This is input A, input B, and we have 2 inputs. So we have 4 possible combinations: 0, 0, 1, 0, 1, and 1, 0, and 1, 1. So when both the inputs are 0, 0, the output is 0. When input A is 0, input B is 1, the output is 0. And when one is input A is 1, input B is 0, the output is 0. When both the inputs, input A and input B, are 1, the output is 1. So this is the truth table. It summarizes the operation of a logic circuit. A truth table basically summarizes, it lists all the possible combination, input combination with corresponding output, and summarizes the operation of a logic circuit. So this is what a truth table. This is the truth table of an AND gate. So AND gate produces a high output if all the inputs are high, otherwise the output will be low. An OR gate, the next gate is OR gate. An OR gate can have two or more inputs and perform what is known as a logical addition. Keep in mind, in digital design we have two types of addition. One is logical addition or Boolean addition, and the other is binary addition. Binary addition return the rules of binary. If we look at the rules of binary addition, so in binary addition 1 plus 1 always equal to 1 0, 2 in decimal, while in logical addition 1 plus 1 equal to 1. So our operation is equivalent to logical addition. The OR gate implements OR logical operation. The OR gate is composed of two or more inputs and a single output, as indicated by the standard logic symbol. This is what the standard logic symbol of an OR gate. On the left side we have inputs. This is two inputs, A and B. Logical operation or logical operation is basically a binary operation, so at least it requires two operands. So for two input OR gates, we have two inputs A and B on the left side, and we have a single output on the right side. X is the output. Operation of OR gate. An OR gate produces a high on the output when any of the input is high. If A is high, the output will be high. If B is high, the output will be high. If both A and B are high, the output will be high. The output will be low if both the inputs A and B are low. So if this is low or 0, this is 0, so the output will be 0. The operation of OR gate can be stated as for a two input OR gate, output X is high when either input A or input B is high, or when both A and B are high. X is low only when both A and B are low. So again we have two inputs, so we have two possible combination, four possible combinations. So these are the four cases for the four possible combination of the inputs. Here when the inputs, both inputs are low, the output is low. When one input is low, the other is high, the output is high. When one input is high, the other is low, the output is high. When both the inputs are high, the output is high. So look, this is a different case. The OR gate generate a low at its output only if all the inputs are low. All the inputs, it generate a 0 at the output if all the inputs are 0. The Boolean expression of an OR gate is given as A plus B. This plus sign, this represent an OR operation. This represent Boolean addition. The truth table of two input OR gate. So again we have two inputs, so we have four possible combination of input. So the first combination is 0 0. When both the inputs are 0, the output is 0. When any of the inputs, in these three cases, when any of the input or both inputs are high, the output is high. This is 0 1. For 0 1 the output is high, for 1 0 the output is high, for 1 1 the output is high. So this is what an OR gate operation. The NAND gate. The NAND gate is called a universal gate. This is a very important gate. So it's called universal gate because through NAND gate we can implement other logic circuits, other gates. We can construct OR gate using NAND gate. We can construct AND gate, NOT gate using NAND gate. That's why it is called a universal gate. The term NAND gate is contraction of NOT AND and implies an AND function with a complemented inverted output. The standard logic symbol for two input NAND gate is shown in the figure. Look at this figure. We have this is the symbol of two input NAND gate. We have A and B input on the left, and we have a single output on the right. So this is a bubble. The bubble shows again the bubble shows a complementation. So and it inverts AND operation. Basically it inverts AND operation. So this is the symbol of a NAND gate, two input NAND gate. Operation of a NAND gate. A NAND gate produce a low output only when all the inputs are high. If A is high, B is high, the output X will be high. If A is 1, B is 1, the output X will be 1. If any of the input is low, the output will be, if A is a high, B is a high, X is low. If A is 1, B is 1, X is 0. The output is 0. If any of the input is low, the output will be high. A NAND gate produces a low output only when all the inputs are high. When any of the input is low, the output will be high. NAND gate operation. The NAND gate operation can be stated as, for a two input NAND gate, output X is low only when input A and input B are high. X is high when either A or B is low, or when both A and B are low. So look, this is we have two input NAND gate. So we have four possible combinations of the inputs. So for 0 0, the output is high. For 0 1, the output is high. For 1 0, the output is high. And for 1 1, only for 1 1, when all the inputs are at same logic level, the output will be low, 0. The Boolean expression for the output of two input NAND gate is X is equal to AB bar. This is the Boolean expression, AB whole bar. The operation of a NAND gate can be summarized in a truth table. So again, we have two inputs, we have four combination, and this is the output column. So for 0 0, the output is 1. For 0 1 combination of the inputs, the output is 1. For 1 and 0, the output is 1, and for 1 1, the output is 0. When both the inputs are high, both inputs are 1 1, the output is 0. This is operation of a NAND gate. NOR gate. Like NAND gate, NOR gate is also called a universal gate for the same reason. We can construct any logic using NOR gates. But keep in mind, most widely used gate is NAND gate. The term NOR is a contraction of NOT OR and implies an OR function with an inverted complemented output. The standard logic symbol for a two input NOR gate is shown in the figure. So look at this figure. Again, these are a two input NOR gate. So A, B are the inputs on the left, X is the on the right is the output, and this bubble shows we have complemented OR operation. So NOR gate basically complements OR operation. If we can complement OR operation, we get a NOR operation. Operation of a NOR gate. A NOR gate can produce a low output when any of the input is high. If any of the input is high, if A is high or B is high or both are high, the output will be low. When both the inputs are low, then the output will be high. When all of its inputs are low, the output is high. For a two input NOR gate, the operation of a NOR gate can be stated as for a two input NOR gate, output X is low when either input A or input B is high, or when both A and B are high. X is high only when both A and B are low. So again, we have four cases because we have two inputs. This is a two input OR gate. So this is the first case when both the inputs are 0, the output is high. When 0 1, the output is for 0 1. When the inputs are one input is 0, the other is 1, the output is 0. When one input is 1, the other is 0, the output is low. When both the inputs are high, when both the inputs are 1, the output is low, 0. So this summarizes, this figure summarizes the operation, the four possible cases of a NOR gate. The Boolean expression for the output of two input NOR gate can be written as A plus B whole bar. A plus B whole bar. So the truth table again summarizes the operation. This is the truth table of NOR gate. It summarizes the operation of the NOR gate. So we have two inputs. We have four possible combinations: 0 0, 0 0 for this case, 0 1 for this case, and 1 0 for this, and 1 1 1 1 for this case. So 0 0, the output is 1. And for the remaining, when any of the input is high, in these three cases, one or two inputs are high, so the corresponding outputs are 0. This is the operation of NOR gate. The next gate is the exclusive OR gate. Exclusive OR gate is a two input gate. Standard symbols of the exclusive OR gate is given in this figure. Look, this is the standard symbol of exclusive OR gate. Again, this is a two input gate, so we have two inputs A and B and a single output on the right X. The exclusive OR gate performs modulo 2 addition. In modulo 2 addition, 1 plus 1 is equal to 0, 1 plus 0 is equal to 1, 0 plus 1 is equal to 1, and 0 plus 0 is equal to 0. So it performs basically modulo 2 addition. The output of an exclusive OR gate is high. Output of an exclusive OR gate is high only when the two inputs are at opposite logic level. So if A is 1 and B is 0, X will be 1. If A is 0 and B is 1, X will be 1. If A and B are at the same logic, for example, if both are 0 0, the output will be 0. If both are 1 1, the output will be 0. The operation of exclusive OR gate can be stated as: for an exclusive OR gate, the output X is high when input A is low and input B is high, or when input A is high and input B is low. X is low when A and B are both high, are both low. So these are look at these two cases. Inputs are at the same logic. So if all inputs are at the same logic, the output is low. If both the inputs are at different logic, means one is 0 and the other is 1, the output is high. This is the truth table of the exclusive OR gate. It summarizes the operation of exclusive OR gate. So we have two inputs, so we have four possible combination. This is the first combination: 0 0, 0 1, 1 0, and 1 1. So when A is 0, B is 0, the output is 0. When A is 0, B is 1, the output is 1. When A is 1, B is 0, the output is 1. So look, for these two combinations, the output is 1 1, because both are at different logic level, opposite logic level. And for this case, for the first case and the last case, when both are 0 0 or both are 1 1, so the inputs are at the same logic level, so the output is 0 for both cases. This is the operation of exclusive OR gate. If we put a bubble or put an inverter at the output of exclusive OR gate, so we get an exclusive NOR gate. Standard symbol of exclusive NOR gate is shown in the figure. This is the standard symbol, A and B, and this bubble shows the complementation. So without bubble, this is an exclusive OR gate. When we put a bubble, so we complement the operation of exclusive OR gate, so it becomes an exclusive NOR gate. The bubble on the output of exclusive NOR symbol indicates that the output is opposite that of exclusive OR gate. When the two inputs, the operation of how it operates, how it works, how an exclusive NOR gate works. So when the two inputs input logic levels are opposite, the output of the exclusive OR gate is low. When they are at opposite logic level, means if this is 1 and this A is 1 and B is 0, or B is 1 and A is 0, A is 1 and B is 0, the output will be low. When both the inputs are at same logic level, means if A is 0 and B is 0, the output will be high, the output will be 1. If A is 1 and B is 1, again the output will be 1. So the operation can be stated as: for an exclusive NOR gate, output X is low when input A is low and input B is high. are when A is high and B is low. X is high when A and B are both high or both low. So in these two cases, both the inputs are at the same logic levels, and for these two cases, input are at different logic levels. So when the inputs are at same logic level, the output is 1, and if they are at different logic level, the output is 0. This is the truth table of exclusive NOR gate. Summarizes the operation of exclusive NOR gate. So when both the inputs are at same logic level, means 0 0 or 1 1, the output is 1. When both the inputs are at different logic levels, the output is 0 0. This is all about logic gates. Thank you very much.